So some of the innovations on the new HP Latex 300 printers relate to the curing system and the media management. Ramon, can you help us to understand those a bit better?
There are several new innovations. Where would you like to start?
So let's maybe start with the high-efficiency curing system. What exactly is this?
Well, you know that now we print high image quality at faster speed.
Yes, thanks to the HP Latex Optimizer.
Correct. But printing faster means curing faster, and this is what the high-efficiency curing system is about. It is not only able to cure faster, but also cures at lower temperature and uses less energy to cure.
Sounds very promising. So how does it work?
So the operation principle is very simple. It's using hot air, but the trick, as always, is the details. Everything starts here, so these heating elements blow air inside of the curing module. Inside of the curing module, the airflow stabilizes for temperature, for speed, and for pressure. And then the air exits the curing module through hundreds of small nozzles and it's blown onto the substrate. These microjets of hot air are able to cure the ink, but are not damaging or are not deforming the substrate.
That's very good. And why the printer prints faster then?
There are two reasons. First one is this guy to blame. These heating elements go from 0 to their operating temperature in just a few seconds. This enables the printer to go from standby to ready to print in less than 2 minutes.
And the second reason?
The second reason is that we use convection as the heat transfer mechanism. This is very efficient, so this enables to use lower temperature and to submit the substrate to this temperature during a shorter time. Then we are able to either print faster using the same power or to print at the same speed using half of the power.
So what about media? Is there any difference in the medias we support with the new HP Latex 300 printers?
There's plenty, but I think that Eli can give you more details on this.
Hi, Eli.
Hi, Joan. Yes, as Ramon said, the high-efficiency curing operates at lower temperatures, applied over less time. This reduces the thermal stress applied on very heat-sensitive materials.
And can you be a bit more specific?
Sure. Let's take, for example, a very commonly used low-cost banner. These materials are sensitive to high temperatures. When you apply heat on them, they can deform in two different ways, from the sides towards the center and along the job. The high-efficiency curing is preventing these deformations from happening.
Okay, so does this mean that with the new HP Latex 300 printers, do we support more materials now?
Not really. We are already supporting many types of materials. The difference now is that we are able to print faster, with a better quality, on heat-sensitive materials.
Yeah, but you know, HP Latex is always about doing more applications, so aren't we really supporting more substrates?
Yes, in fact, we are now supporting polypropylene films like this one, and also with the HP Latex 360, we are able to print on very porous materials such as mesh or textile, thanks to the ink collector.
The ink collector. So, Ramon, what is this exactly?
So this is a very clever design. So what you have here is a print platen. This print platen is used for non-porous substrates like paper or vinyl. This is what's usual inside of the machine. But if the operator can replace this by the ink collector. And this ink collector is used for high porosity materials like, for example, mesh. Then the ink that gets through the material is collected by these foams and then the printer is not ink stained.
That's very good. So let me try to summarize. We have a new high-efficiency curing system that helps us either to print faster or reduce the energy consumption, help us to improve performance on very heat-sensitive materials, and also enables us to print on more applications like polypropylene films. Also, we have an ink collector that helps us to print on porous medias like textiles and mesh. Did I get it all correctly?
Absolutely, 100%.
You got it, Joan.
Thank you. That was very useful. Thank you, Eli and Ramon.
You're welcome.